Welcome back, Logan, to another installment of Math from Your Couch. Today's topic is going to be on inscribed angles, and let's take a look at what an inscribed angle looks like. And there it is. So you'll notice that inscribed angles are angles that are inside the circle. Different from a central angle is that the vertex of the angle is not located at the center. You'll notice that the inscribed angle is made up of two chords. Our first chord is, I'm going to call it chord AB, and our second chord we'll call chord BC. So an inscribed angle is made up of two chords, and the vertex of the angle lies on the circle, not at the center, kind of like central angles, so this is a little bit different. And this right here is going to be our definition of what it means to be an inscribed angle. Inscribed angles are angles that are formed by two chords where the vertex of the angle is on the circle. Now, a byproduct of this is going to be that arc right there, arc AC. We're going to call this arc the intercepted arc. So angle B intercepts arc AC. That's because arc AC is inside of the angle, and this leads us to our definition of an intercepted arc. Intercepted arcs are arcs that lie inside the angle. So arc AC is the intercepted arc of angle B. And let's write that down real quick. So we got arc AC is the intercepted arc, and angle ABC is the inscribed angle that intercepts that arc. And this is our definition. So what we're going to do is we're going to take a look at the relationship between the yellow and the green, the relationship between the yellow and the green. And this leads us to that property. The property states that the measure of the inscribed angle, so that green guy right there, right, so the green angle, the measure of the inscribed angle is going to be half of whatever the arc is. So the green is going to be half of the yellow. And this is how I would write it as a shortcut. If you take half of the arc, you're going to get the angle, all right? So half the arc equals the inscribed angle. Or if you were to double the angle, that will equal the length, or the measurement, sorry, of the arc, okay? So those are the two things. Cut the arc in half, get the angle, or double the angle to get the arc. Now, this only works for inscribed angles. Please don't try this on central angles or any other angles with circles, just the inscribed angle. All right, take a look at our first example. Example number 1. So what we got here is an measurement of angle B is 50 degrees. So we have the measurement of angle B is 50 degrees, and the measurement of arc BC comes out to 80 degrees. So what we're going to do is we're going to figure out what is the measure of angle D and what is the measure of arc AD. Sorry for that mess up right there. So what we're going to do is we're going to use the theorem, use the property that's right up above, but I'm going to use the shortcut. I'm going to say this, is if you take the angle and you double the angle, you'll get the arc. So if we take the angle and double it, we should get the arc right here. So if I double to 50, that's going to give us 100 degrees. So we now know that arc AD is 100 degrees. All right, or if you have the arc and you cut the arc in half, you should be able to get the angle. So the angle is equal to 40, as long as the angle is an inscribed angle for that intercepted arc, which it is. So we now know that angle D is 40 degrees. All right, moving on to example number 2. In example number 2, we have this circle here where arc RQ is 90, arc RT is 150, and we're trying to find the measure of angle R. So since I know I'm trying to find the measure of this angle right here, I need to take a look at this arc. Unfortunately, I don't have this arc. What I have is arc RQ is 90, so I know this arc over here is 90 degrees. And I know that arc RT is 150 degrees. So arc RT is 150. So they gave me everything except for what I needed. I needed QT. The good news is I know what everything should add up to. All three of these arcs, 90 and the 150 and QT, the 90 plus the 150 plus the measure of arc QT, all three of those should give me the measure of the entire circle's angle, and a full circle is a 360. So we have 360 degrees. All right, so now we just need to solve it. Combine like terms, this gives us 240 plus the measure of QT's arc plus the measure of arc QT is equal to 360. Solve it by subtracting the 240 from both sides, and the result is that the measurement of arc QT is going to equal 120 degrees. So I now know that this measure of the QT arc from there all the way to over there is going to be 120 degrees. Now remember, if we take the arc and cut it in half, we will find the angle, which will equal 60 degrees. So I found what angle R is. It's 60 degrees. Example number 3. All right, very similar problem. We have an inscribed angle. The inscribed angle is M with the intercepted arc of ln, and we know that ML is 110. So I now know, or I can write down that this arc right here is 110 degrees. So this arc is 110. The problem is I don't know what ln is, and I don't know what this is. But if I look closely, I notice that mn is a diameter, right? It goes through the center, which means mn cuts the circle in half. So this is a semicircle. And if you recall, semicircles have a measure of 180. So we now know that this arc right here, this semicircle, is 180 degrees. And I can do the same thing I did on the last problem. Regardless of how many arcs I have, if you were to add them all together, and if they gave you the whole circle, all of the arcs should add up to 360 degrees. So I'm going to take the 110, I'm going to take the 180, and then I'm going to take the measurement of arc ln and add them together and get a total of 360. All right, the 110 and the 180 comes out to 290. And now I just need to solve for ln by subtracting the 290 from both sides. And the measure of arc ln is equal to 70 degrees. All right, so I now know that this arc right here is 70. So if you recall, if you take the arc, you just have to cut it in half, and you'll get the angle, the inscribed angle. So our inscribed angle is 35 degrees. Our answer is that angle M is 35 degrees. All right, now, before we go to our last example, I kind of want to take a look at one more thing. So imagine I have a circle, and we just focus on an arc. We have arc AB. Now, what I can say about arc AB is I can draw a lot of different inscribed angles for that arc, that intercept that arc. All right. For example, my first inscribed angle could be this angle right here, angle D. Angle D intercepts arc AB. However, just because it is an inscribed angle doesn't mean it's the only one. I could also draw that one. Angle C also is an inscribed angle that intercepts AB. But you'll notice that these two angles, which are different, intercept the same exact arc. All right. Now, since they intercept the same exact arc, and they're inscribed angles, and they intercept the same arc AB, I can actually logically conclude that those two angles are going to be congruent to each other. And this is what our second property says. Our second property essentially says that if two inscribed angles have the same exact intercepted arc, then those two inscribed angles must be congruent to each other. So as long as two inscribed angles have the same intercepted arc, we will know that those two angles are congruent. All right, let's try to put this property in motion with our last example. So suppose we have angle A, which is 46 degrees, and angle C, which is 39. So angle A is 46, and angle C is 39. You'll notice that angle A intercepts BC, and angle C intercepts arc AD. All right. First question, find the measure of angle B. Angle B. Angle B is located right here. Angle B intercepts AD. I also noticed that AD is intercepted by angle C. So since angle C and B intercept the same arc, using the theorem that's up here, I can logically conclude that they should be exactly the same. So those two angles are going to be 39 degrees each because they have the same exact intercepted arc. All right, second question, what is the measure of arc BC? So I want to find out this guy right here. Now I could know this answer easily if I knew what angle D was, because angle D is the inscribed angle that intercepts arc BC. Unfortunately, I don't have that. The good news is that this angle, angle D, is not the only angle that intercepts arc BC. There's a second angle that intercepts arc BC, and it is here angle A. Since angle A intercepts arc BC and angle A is inscribed, if I just double this angle right here, I will get arc BC. So if I take the 46 and multiply it by 2, this will give me arc BC, doubling the inscribed angle, which is 92 degrees. All right, this is our last example. Please take a look at the assignment, do as many problems as you can. If you have any questions, either email me or hit me up on Google Classroom, and I'll get back to you as soon as possible. Hope to talk to you guys really soon, and otherwise, best of luck. Bye.